Welcome to MS 100 lessons, and in this lesson we'll be doing vertical projectile motion, velocity time graph. So firstly, I'd like to explain why do we have to represent vertical motion in terms of a graph, and how do we interpret this vertical projectile motion velocity time graph. So the main aim of representing motion of a projectile in a graph is to simplify things, right? So it's to bring the information about an object into a picture, so it's easier to look at a picture than to read a statement. So if we look at the example that we have, which says a ball is thrown vertically upwards from the top of a building. So if you try to analyze this type of a question, it's a statement question, right? So there's a lot of wording involved and there's a lot of English involved. So sometimes you might be reading the statement and along the way you get lost on what's happening with the object, right? But however, if you try to convert this information into a picture, it's easy to see what's happening with the object, right? So, and that picture that we'll be using, so there's three different kinds of the velocity time graphs, but specifically for this video I'll be explaining the velocity time graph. So we'll be explaining how the velocity changes as time goes on, right? So we can fully agree that the aim of this topic is to actually eliminate all this wording that's up here, right? So it's also, you can also see that on this question we also have a diagram, right, which simply explains what's happening with the objects. Like someone can see that the object was thrown upwards, it went up, it reached a maximum height, and then it came back right to the ground. So if you see things in a picture, it's easier to explain, or it's easier to understand. So if we can convert this information, which is this wording up here, into maybe a velocity time graph, it's going to be easier to see what has happened with the object, right? But then now, where do we actually start when we explain these velocity time graphs? So to explain these velocity time graphs, we have two scenarios, right? So the first scenario is that a ball is dropped. Okay, so you drop a ball from a stationary point. Okay, so meaning the initial velocity is 0. So that is the first scenario. And the second scenario that we have is when a ball is thrown. Okay, so meaning if a ball is thrown, it has an initial velocity, so the velocity is not equal to 0 initially. But however, if you drop an object from a stationary point, then this means that your initial velocity is equal to 0. So these are the two scenarios that we'll use to explain this velocity time graph. Okay, so let us understand the information that we get behind these two scenarios, right? So the first scenario, which is dropping an object from a stationary point, you can simply agree that the initial velocity of this object is equals to 0, because you are dropping something from a stationary point, right? So it's a drop, it's not, you're not giving it an initial velocity. But however, if an object is thrown, then it means the initial velocity is not equals to 0. There is a certain initial velocity, right? For an example, we can say the initial velocity was 2 meters per second, right? So now before we can say the ball is thrown upwards or downwards, right? We simply have to understand whether is it a throw or is it a drop. So if it's a drop, the information that you have to extract is that the initial velocity is equal to 0 meters per second, right? And then if it's a throw, what you have to note is that the initial velocity is not 0 but a certain value. So for most of the examples that I make when I'm explaining a topic, I usually use the system of axis as to the right as positive and to the left as negative, right? But then now this is a vertical projectile motion, so we'll be working on the vertical axis only. So on the vertical axis, I usually say upward is positive and downwards is negative, right? So now we can actually use this system of axis to explain whether this positive 2 is positive or negative for a ball or for an object that is thrown, right? So like for example, if we choose upward as positive and downward as negative, as I've shown in this diagram, if this ball is thrown upwards, right, then it means this would be positive 2 because we're saying upward is positive and the ball is thrown upwards, right? So this would be positive. But however, if we say this ball was thrown downwards, right? If this ball is thrown downwards, then it means we have an initial velocity of negative 2 because we said upward is positive and downwards is negative. And if the ball is thrown downwards, it follows this negative part, right? So it means that 2 would be negative 2 meters per second, right? So the sign of the velocity, it depends on the direction that you have chosen, and it depends on where the ball is going. All right, so we have answered our first question into explaining these velocity time graphs, right? So the first question was it a drop or a throw on that object, right? So we have said that if it's a drop, your initial velocity, then it's equals to 0. And then if it's a throw, then there is a certain initial velocity, whether it's thrown upwards or downwards, that will be determined by the system of axis that we have chosen. Okay, so graphically, so how do we represent these two scenarios at the starting point, if it's a throw or if it's a drop, right? So on a graph, say we have your y-axis, which is your velocity axis, and your x-axis, which is your time axis. Okay, and your time is in seconds, your velocity is in meters per second. Okay, so that is a velocity time graph. So let me do for both scenarios. So this would be for the first scenario for the drop, and this would be for the second scenario for the throw. Okay, so mind you, for this example, we're going to be using this system of axis whereby we say upward is positive, right? Okay, so let us look at an object which is dropped in terms of a graph, right? So at this origin point, this is where we have your time equals to 0 and your velocity equals to 0, right? And then on the top of the axis, this is the positive velocity, and below this 0 point, this is your negative velocity, right? So that is negative velocity, that is positive velocity, and this is why velocity is equals to 0. Okay, so now let's say an object was dropped. So what does that mean? So initially it means that the initial velocity is equals to 0. So if you go to your time axis where t is equals to 0, what will be your velocity? So your velocity would be equal to 0 also. So it means that your graph would start at that point, right, which is the origin, because it's a drop and it's dropped from a stationary object. So your initial velocity is equals to 0. So every time a graph starts from this origin, you'd have to understand that this ball or this object, it was dropped from a stationary object because the initial velocity is equals to 0, right? So now let us look on the other hand. Let's say this ball was thrown, say upwards. Okay, so if it was thrown upwards, then we can agree that upward is positive and our velocity would also be positive, right? So that would be positive 2. So now how do we represent this throw on a graph? So let us go back to our graph and label that is the origin, right? The 0 point where your t equals to 0 and your velocity is equals to 0. And this is your negative velocity, that's your positive velocity above this 0 line, okay? So now what is the initial velocity? The initial velocity is equals to positive 2 because we chose upward as positive. So that is 0, maybe this is 1, that is 2. So this is where your graph is going to start, right? So if you look at the two differences, was it a drop or a throw? If you look at this graph, it starts at 0. Then you can simply say this was a drop from a stationary object, right? But then if you come on the right hand side on this graph, was it a drop or a throw? If you look at the point where it starts initially, it does not start at 0, right? So meaning this object or this ball, it was thrown and it was not dropped from a stationary object. So these are the two differences. So when you explain this type of a graph, you have to explain from the moment the movement started, right? At t equals to 0. At t equals to 0, velocity equals to 0, that is a drop from a stationary object. And if there's an initial velocity, then it's a throw, right? So maybe let's say it was a throw, right? And it was thrown downwards, for example, then it means your initial velocity is equal to negative 2 meters per second, right? Because we chose upward as positive and downwards as negative. So still, if your velocity or your initial velocity is equal to negative 2, that point would be somewhere here as negative 2, that is negative 1. So you can still see that this point is not on the origin, because if it's on the origin, then it becomes a drop. So it's either a throw or a drop, right? But if it's a throw, it does not start at 0. So those are the two differences that you have to bear in mind when you answer this type of a question or when you explain this type of a question. All right, so the second question now, the second question that follows, was it a drop or a throw? The second question that follows is, where did the object go, right? So where did the object go, or where did the ball go, right? So it's either the object can go upwards or the object can go downwards, right? Because it's a vertical projectile motion. It's either up or down, okay? But now let's explain for the first scenario, which is a drop, okay? So if you drop something from a stationary object, your initial velocity is equals to 0, right? So let's say, for example, we have a person on top of a building holding this ball here, right? And that person is stationary on top of the roof. So if this person drops that ball, that initial velocity is equals to 0, right? And how do we represent that on a graph? We have seen that on the velocity time graph, your initial point would be at the 0 point, right? But now, where did the object go? So after dropping that object, where do you think the object can go? I don't think, if you can drop something, right, and under the influence of gravity, remember we are dealing with objects under the influence of gravity. So if you drop something, you expect that object to go down, right? So in terms of when the ball is dropped from a stationary point, it's obvious that the object went down, right? So we don't have to explain this one. The object went downwards towards the earth, right? Due to the force of gravity. This is for the drop. But now let's check for the throw, okay? So when you throw an object, two things may happen. The object can go up, right? You can throw it up, or you can throw the object down, okay? So if we can have a similar picture as the one on the left, we have a person on top of this building holding this object, right? And same picture again, we have a person on top of a roof holding a ball. So if this person throws this object upwards, we expect the motion to be like that. It will go up and then it will reach a maximum height and then it will go down, right? So initially, when this person throws this ball, this person threw this ball upwards, right? So the ball went upward. So now our task is to actually identify from the graph where did the ball go, okay? And then also it's possible that this person throws the ball downwards with an initial velocity. So we expect the ball to go downwards. Okay. So now we said if it's a drop from an initial, from a stationary point, the initial velocity is equals to 0 and the drop will make the object to go down, right? But however, if it's a throw, how do we actually see it on a graph? Okay. So let us go back to the first scenario to say that this ball was thrown upward, right? So if it was thrown upwards, your velocity becomes positive 2, which is up there, which is this positive 2 right here. So let us see the motion. If we throw the ball upwards, right? If we throw the ball upwards, we expect it to slow down up until it reaches the maximum height. And at the maximum height, that velocity is equals to 0 meters per second. Okay, so we are throwing this object with a velocity of 2 meters per second, right? Upward. So you expect the object to reach a maximum height. And at the maximum height, your velocity is equals to 0. So let us represent that on the graph. So if you throw that object upward, you're throwing it with an initial velocity of 2. There we have our point, right? But we expect our velocity to decrease. So if our velocity is decreasing and it should reach 0, then it means this graph would look something like this. It will decrease up until it reaches a velocity of 0 down there. So when it reaches this velocity of 0, we can simply say this has reached the maximum height. Because at the maximum height, your velocity is equals to 0 meters per second. So we can see that if you throw something and it reaches a maximum height, it means you're throwing it up, right? So, but what if we throw that object and we throw it downwards like that? What if we throw that object and then we throw it downwards? So we expect the object to go downwards and it must bounce at the floor or at the ground, right? So it means if you throw an object downwards, you expect it to bounce first, right? But then if you throw the object upwards, you expect it to reach a maximum height. And where is your maximum height? Your maximum height is whereby the velocity is equals to 0. Okay. So let's have maybe a mini example. So let's say you have a graph like that. That is 0. And then you have a throw. Okay, so why do I say it's a throw? That's because the graph does not start at 0. My point starts at a certain initial velocity. In this case, it's -2, right? So now let us forget about the direction for a moment. I just want us to actually decide whether this ball was thrown upwards or downwards, right? So say you have a ball which is thrown and you get a graph like that. So when this ball was thrown, right, it was thrown and it went to bounce. So it first bounced, right? So if it bounced, then it means this was thrown downwards, right? But then if the ball was thrown and it reaches a velocity of 0, then that is your maximum height, right? So it means this ball was thrown upwards. So if you throw it and then it bounces, it bounces first, then it means it was thrown downwards. And then if you throw it and then it reaches a maximum height like that, then it was thrown upwards, right? So those are the first two questions that we have to answer. The first question is, was it a drop or a throw? You look at the starting point. Is it 0 or is it a certain initial velocity? If it's 0, it's a drop. If it's a certain initial velocity, then it's a throw. And then number 2, where did the ball go? If it's a drop, we said obviously it's gonna go down, right? But then what if it's a throw? How do you decide whether it was thrown upwards or downwards? So if it reaches maximum height first, then it was thrown upwards, right? And then if it bounces first before it reaches the maximum height, then it was thrown downwards, right? So another example similar to this one, we can say we have a velocity time graph. That is your velocity and that is your time, right? And you get a graph like that. So first question is, was this a drop or a throw, right? So let us look at our initial velocity. What is our initial velocity? In this case, our initial velocity is equal to 0. Then we can simply say this was a drop from a stationary object, right? Question number 2, where did the ball go? If it's a drop from a stationary point, the ball is expected to go downwards. And if it goes downwards, it's gonna go downwards and bounce, right? All right, so another example, say we have our velocity time graph. Okay, and then that is 0, 1, 2, -1, -2. And then we have our starting point there. So question number 1, was it a drop or a throw? We check that using our initial velocity. Our initial velocity is equal to +2 meters per second. Okay, so it means that was a throw. But then what if my graph does that? What does that mean? So it means, fine, the ball was thrown, but it reaches maximum height, whereby the velocity is equal to 0. So what does this mean? Was it thrown upwards or downwards? In this case, we can say it was thrown upwards because it reaches a maximum height. Last example. Let's say we have our velocity time graph. That is velocity and this is time. And we have a graph like that. So it's important to note that this is the initial phase of the motion, right? Like from the start of the motion, was it a drop or a throw? Okay, and then we'll in the next video we're going to explain when the ball bounces, maybe multiple times or twice. All right, so let's answer the first two questions. Question number 1, was it a drop or a throw? So we can see that our initial velocity is not 0, right? It's here at -1, so meaning this was a throw, right? And then if it's a throw, where did the ball go? Was it thrown upwards or downwards? So if we check, when this ball was thrown, it first bounced. This is a bounce, right? Before it reached maximum height. If it reached maximum height, it would have a graph like that, and then it reaches maximum height, which is velocity equals to 0, right? But in this case, we can see that after the ball has been thrown, it went to bounce, right? So this simply explains that the ball was thrown downwards. So this is all for this part one. For the velocity time graph, we are just trying to convert this statement into a graphical representation, right? And specifically for this video, it was the velocity time graph. So the first phases or the first stages of explaining this velocity time graph is to identify whether the ball was thrown or it was dropped from a stationary point, right? And now we can explain that using the initial point on that graph. If the initial velocity is equals to 0, then we can say that there was a drop and the initial velocity is equals to 0 meters per second. And then if the ball was thrown, we can see that the initial velocity is not equals to 0. It can either be on the positive side or on the negative side, depending on the direction chosen as positive, right? But for these examples, we're saying upward is positive, okay? And then the second question was, where did the object go? Was it thrown upwards or was it thrown downwards? Because if it's a drop, we said obviously it's going to go downwards due to the gravitational force, okay? And then if we were to identify whether it was thrown upwards or downwards, we check whether the object reaches maximum height first or it bounces first, right? So if it reaches maximum height first, whereby the velocity is equals to 0, then we can say that the object was thrown upwards. However, if the object bounces first before it reaches maximum height, then we can simply say the ball was thrown downwards. So in the next video, which is part 2, we'll be explaining the direction and further explanations on this vertical projectile motion velocity time graph.